bracket. After that, just suppose 1 to 10, then 1 space 2. I can use comma also, 1 comma 2 comma 3 comma 4. So once I have done, if I run it, it will be like equal to 1 to 10. Is it clear to everyone? So Shivam, suppose I have
Yes,
to
sir.
extract the third element of this matrix, which is A. So what will be A3? What is the third element of this matrix A?
So the 3.
So it is 3. Clear? Suppose I have to add second and fourth element, how I will write? It will be like this. So what will be the answer, Shivam? Is it right or not?
Right, sir. 6.
One more thing, like how I have written A equal to 1, 2, 3, 4, 5, 6. So one more way to write this, suppose I am writing A1, so I can write 1 colon 10. It means once I have written like this, na 1 to 10 or 1 to 100, 1 colon 10 or 1 colon 100. So it will generate the values from 1 to 10 with difference of 1, means in sequence. So if I click it, we can see the same is generated. Is it clear to everyone?
Yes, sir.
Suppose if I want to have gap of two numbers, so how I can write? Suppose I am taking a variable a2, I can write 1. The gap should be 2, and it should be from 1 to 10. So it will display the values of 1 to 10 with gap of 2. So if I enter, you can see it will be like 1, 3, 5, 7, 9. So Amit, is it clear to you? Sumit?
Yes, sir.
Is it clear to you?
Yes, sir. It's clear.
Okay. So one more function is there in Matlab. It is ran, when you have to generate random numbers. So suppose I'm giving a variable a3 and I have to generate random numbers. Okay. So suppose I have to generate random numbers of one row, 2 columns. So I can write in display 1, 2. So you can see 2 values are there. One more thing, suppose I have to generate three three rows, 4 columns, means a matrix of 3 cross 4. So in many experiments, you may need to generate random numbers. So we can use this function. And if you want to see the functions which are related to random numbers, so you can type here rand. You can look for the descriptions. Yes. So you can find descriptions here about what is rand. So rand n here returns an n by n, if it is written n by n matrix containing pseudo random values. Okay. And if you want to generate integers only, you can use randi, rand I. And you can also look for suggestions. You can also look for suggestions. You can see there are many functions like rand, rndi, rand n, rand permit, rng, aspirand, aspirand n. So there are many options you can explore from here. So if you are coming to know any function, just search here, look for the suggestions. In this way, you can learn many more functions. Okay. I'm audible.
Yes, sir.
Yes, sir.
So in this way, you have to explore by yourself about functions in Matlab, about tools in Matlab, how you can do all these things. So, and suppose you have to plot something. Suppose I have x equal to 1 to 10. Suppose I have y equal to 10, 10, 10, 10, 10. 1 to 10. And I have to plot it. So I can write simply plot x comma y. So you can see a line here. So whatever variables you have generated, or whatever information you are having, you can use plot function. There are many functions in plot also. So you can search here in the search box, and you can see how many functions are available for plotting purpose. What if I want to do with some? I don't want line. I want to do with some points. So I will write like this. I will enter. You can see you can get the plot by like this. And I was talking about sum also. So you can see the value of a here. A is having from 1 to 10. So if I write sum a, so it doesn't matter how many elements are there, all elements will be added. So you can see sum a equal to 55. So it was just about row matrix. Suppose you have to create a matrix by your own. So you can write 1, 2, 3, 4. So these are the values for the row. Suppose you have to change it to second row, then you can place here a semicolon. Now the line is changed. Now you can fill other values also. Suppose 2, 4, 3, 1. So if I enter, you can see it is 2 cos 4 matrix. So these are the basic things you will be doing with it, you will be learning. One more thing, I think I have not taught you using loops in Matlab. Have you learned loops in Matlab?
What, sir?
Loops.
No, sir.
No, sir.
Okay. So we'll see if we have time at the end of the class. Then we'll discuss about loops. Okay.
Sir,
Yes.
array index number will start from 0 or 1 in MATLAB.
In Matlab,
Yes, sir.
it's one. You can see the first value in A is 1. Okay. Is it clear?
Yes, sir.
Okay. So now let's come to next thing. In lab, you have to learn that how you can use the total station. Okay. So first of all, tell me how many of you have used the total station? Please raise your hands if you have used. Shivam. Any other student? Alok. No one else? Okay. Yes, Alok.
Yes, sir.
So please tell us about tool station or share your experience with tool station.
Sir, please repeat.
I am asking for please share your experience with total station or what you have done, what you know about total station.
Sir, this instrument used in survey lab to measure angle and distance between points. There is a reflector and a total station where it emits electromagnetic radiation that reflected from the reflector. Then these data is collected in total station, and then we take this in our computer and we measure the traverse.
Okay, what do you mean by traverse? No problem. Shivam.
Yes, sir.
Share your experience with total station.
Sir, the total station is a surveying instrument which I used.
Okay, that's okay. I'm asking about your experience. Mean, have you used this? When you use this, what you were doing with that?
Sir, for layout, for build foundation layout, for road survey.
Okay, so when in when you have used it,
Voice break over.
I'm asking about when you have used it in BTech last year.
No, sir, in my job profession, sir.
Okay, okay, okay. Okay, then let's start. So the one which we are having in our lab, it is a product of Trimble. It is Trimble M3 total station. Okay. So this presentation is on give you a brief introduction of total station, how you can use it. It will be explaining very briefly. So these are the contents which we'll be discussing in this presentation. What is the objective of this presentation means what you will learn from here. I will tell you about total station and the specific total station which we are using. It is Trimble M3. About its feature and specifications and what you can do with the total station, like what advantages and the workflow, like how you can start surveying using a total station. Then a little about traversing and then about contours and contour mapping. So these are the objectives. The primary objective of this laboratory, especially this one, is to introduce you the this is advanced surveying instrument which we are calling the total station. So in past, what we were doing, we were having a means individual instruments for measuring the distance, for measuring the angles. So this total station provides a combination of that. It will measure the distance and angles. It will generate the coordinate system. It will collect your data also. You can export in many formats. That's why we are going to call it total station. So in this presentation, you will get a basic understanding like how you can go for topographic mapping using total station. Traversing will be also explained to you a little in a very as a very brief, and a little about contour mapping. Okay. So what is total station? It is a combination of distance measuring instrument which we are calling electronic distance measurement. Here I am calling it electronic distance measuring instrument. And second thing is the electronic theodolite. So the first one will be used for distance measurement, and second one is for the angle measurement. It is also having many components like it is having microprocessor, it is having electronic data collector, it is having a storage system, so that that can make your surveying operation very easy. So what you can calculate with the total station, it is the horizontal and slant distance. You can calculate horizontal and vertical angles. You can calculate the means you can get the coordinates of the observation points and many more you can see here. So the idea of surveying using total station is like that. First, you will go on the ground. For any area you have to survey, you will generate a local coordinate system. Once that local coordinate system is fixed, it is ready, you will start taking observations. Okay, this is the basic idea what you will do on the field. So in the presentation we will learn how we will what we will do step by step. Okay, so this is the Trimble M3 total station which we are having. This one is the carrying handle. You can carry it, and this is the eyepiece of the telescope, and this is the Doppler ring for the focus adjustment. If you want to move vertical, then you have to use this say axis, and you have to do some horizontal movement. You have to use this one. This is the touch screen from where you have to control this instrument, and this is the try batch on which this total station is placed. If you see on the side view, then this is the carrying handle, and this is the telescope, and this is the line of collimation, the center of this telescope, and this is the battery box where you have to place the battery. If you look at the features of the total station, it is compact and lightweight. It is having a very streamlined workflow. It is bright and colorful touch screen, state and color mechanical technology, and the software which you are using, it is a Trimble access field software, optics, and there are different features you can see. Talking about the specifications on the basis of range and accuracy of distance and angle measurement. So you can see when you are using a reflector seat, then it will be from 1.5 meter to 270 meter, and if you are using the prism, then it will be approximately 3 kilometer. Talking about the accuracy, if you are using the prism, it will be 2 plus 2 ppm into d. D is the distance here, so approximately 2 to 3 mm it will be there. And in the case of reflectorless, it will be a little more. It will be 3 plus 2 ppm into d mm, means approximately 3.5 mm. Talking about the accuracy of the angle measurement, in case of horizontal and vertical, it will be 1 second or 2 seconds. And the weight is 4.2 kg, and the weight of the battery is also given. Talking about the specification of the laser it is using, so it has the option of laser pointer class 2, and its wavelength is about 630 to 680 nanometer, and the description of the output power is also given. For distance, it is using the laser class 1. It is a wavelength of 850 to 890 nanometer, and different descriptions are also given. So here the wavelength and output power of the laser which we are using in the instrument is given. Okay, so what are the advantages of using total station? As I said you, like, why we are calling total station, that's why you can say कि field work will be carried out in a very fast manner. You can also see the accuracy is very high. It is around 2 to 3 mm. And the chances of manual errors or human errors involved in especially reading and recording the observations, because initially what we were doing in past, we were taking the measuring the observation and we'll be writing on the pad, so that there may be blunders. So that has been removed, because whatever the observation has been taken, it will be stored in the instrument. So the chances of manual errors are eliminated, and the calculation of coordinates is very fast and accurate. Yes, corrections for temperature and pressure are also means automatically available in the instrument, so it is automatically corrected. The observation will be corrected, and once the data has been taken, you can go for map making or plotting the contour or cross section. You can do anything. So how you will start the survey? So there are many steps. Like, first, as you have to do station setup, you have to put your you have to make your tool station ready. Then you have to first setting up the tripod. You have to set your tripod. Then you have to center. Centering means you have to focus center your instrument on just over the control point. Third is leveling. You have to level the instrument. 4 is sighting. You have to make your telescope ready for taking the observations. 5th is target preparation and setting, like placing your prism and taking the observations is the next step. And then once you have taken the observations, you have to export your observations to any format you want, in CSV or any format. So look at the first step. So this is the tripod. So the tripod has 3 legs. So first of all, you have to open the tripod legs and you have to locate the tripod directly over the station point. Okay. Then we have to put this tripod legs. You have to press force it, and it will be it will go in the ground. Then you have to level the top surface of the tripod. This is the top surface. Then you have to place your instrument on the tripod. So this was the setting of the tripod. Once you set up, open your 3 legs, put it on the ground, place it over the station point, level it, and place your place your instrument on the tripod head. Okay, so once you place your instrument over the tripod head, you have to attach the instrument and this tripod. So you have to use this mounting screw which is given in the tripod. You have to use that and fix the station, the instrument and the tripod. So this was the first step. Second one is the centering. Centering means what you have done till now. You have placed your tripod over the station point, but it will not be accurately centered. So in centering, what you will do, you will use the instruments which are provided in the instrument. You have to center the setup, the instrument and the tripod. This setup you have to place over the station point. So for that purpose, this is the centering. For this purpose, I have made a video. I will show you that. So after the centering, the next thing is leveling. For leveling purpose, you can see in this figure. Yes. In this figure, you can see these are the leveling screws. These are the leveling screws. So for labeling purpose, you can use this labeling screws. Okay. Here you can see these are the 1, 2, and 1 is the another side. So these 3 labeling screws are given in the try batch so that you can label your instrument. Okay. So we were on. Yes. So these are the labeling screws. So you have to rotate 2 at a time, and you have to see there is a water bubble given in the try batch and given in the instrument also. That we'll see in the video. So that on the basis of that, you have to label the instrument. Once this is done, you have to cite. Okay. So the next step is the citing. In the eyepiece, which I have shown in the figure, in the eyepiece there are crosshairs. Means there will be one line horizontal line and one vertical line, and they will be cutting at the point. We are calling it crosshairs. So first, using the eyepiece, and there is a diopter over this eyepiece, you have to rotate it, and you have to make your crosshair sharp. It, how to see here? Yes. No, it is not shown here. We can see in this way. Once we are ready to take the observation, you have to focus that crosshair on the point you are taking the observation. Okay. So once you are focusing it, you have to use the diopter ring. You have to rotate it in this way that it will be very clear. It should not be dim. It will be very clear and sharp to you to focus on that corner or any point. So the first step is just the diopter. Second thing, there may be the problem of parallax. So what is parallax? Parallax is difference in the apparent position of an object viewed along 2 different lines of sight. How this problem I can explain you. It is like suppose I focused my crosshairs at any object. Okay, then I have to move my eyes means once up, down and up, and left and right. If when I am moving my eyes down and means down and up and down and left and right, the crosshairs should be focused on that point. If I am seeing that it is moving or the object is moving when I am moving my eyes, in that case there is some parallax. And if then we have to focus again using a crosshair and dioptering, you have to focus again. And after doing that, then you have to take the observation when there is no parallax. If parallax is there, it means your observation will not be correct. Coming to the next one, the target preparation and setting.
सर
Yes.
सर प्लीज पैरालैक्स को थोड़ा इजी वर्ड्स में समझाइए.
Sorry.
जो सर आपने पैरालैक्स को बताया कि हम अपने आँख को अप एंड डाउन एंड लेफ्ट एंड राइट मूव करेंगे, और
Yes.
जो मूविंग समथिंग था सर ये क्लियर नहीं हुआ है.
When you are ready to take the observation, there should be no parallax. Okay. So this is our objective. There should be no parallax. What you have to do at that time when you're taking observation, once you have focused your crosshairs on any object, okay, so at that time you have to move your eyes once, means move your head just left and right, up and down. If your crosshairs are not rightly focused, okay, in that case that image will move, means the scene you are looking at, it will move, or the crosshair you means you will notice that our crosshair is moving or the background scene is moving. If it is moving, it means like it is not clearly focused. At that time, you have to use the diopter ring given on the eyepiece. You have to make it sharp. Once it is focused, then there will be no parallax and you can take the observation. Is it clear to you now?
Yes, sir. Clear.
Okay. Okay. So in the this Trimble M3DR series, we have two options of for taking the observation. One is prism mode, means we can place a prism which is given by the means with the instrument. You have to place the prism, you have to take the observations. You have to place the prism, you have to focus on the center of the prism, then you have to take the observation. In many cases, it may not be suitable to place the prism. At that case, you can use the reflectorless mode. In reflectorless mode, it will direct the laser which is uh, uh, yes, the laser which is being illuminated by the instrument, that will directly hit that object, and the whatever whatever energy it is returning to the instrument, that will be recorded. On the basis of that, the observation will be taken. It means once we have prism, and in the second case we don't have prism, we will directly take observation from the objects on which we are focusing. So in the case of prism mode, what we have to see, we have not to use a prism which is having scratches or dirty surface or chipped center. Prism with thin edges are recommended. What is this thin edges? In the prism, once we will see, I will suggest you, everyone, please on the Google you have to search Trimble M3 user manual. Please note it down. Trimble M3 user manual. So every information related to the Trimble M3 total station, that will be provided to you, about the instrument, about the feature specifications. Many of the things we have taken from that document. If you don't, if you are not finding that, let me know. I will provide that document to you. Okay. Let me check. Yes, it is Trimble M3 total station user guide. So when you are taking the observations in prism mode, so prism, so there are some things you have to take care in case of prism. And second thing, when you are taking the observation, your prism should be static. It should not be moving or vibrating. Okay. So yes, here it was written, prism with thin edges are recommended. We can see here in this case. So the first one is okay. It is having thin edges. We can focus on the center. In case of second, it is not good because we don't know what is the center. In third case, this is not thin. Okay, so the first case would be preferred. And in the case of reflectorless mode, how it is taking the observation, the intensity of the reflection from the target, it will determine the distance. Somehow, if this density is changing, sorry, the intensity is changing, suppose due to the reflectance of the surface or anything, so that distance measurement will be changed. Okay. Second thing, make sure there are no obstacle between the instrument and the target. It is very clear that we will not be able to take the measurements. And if the target, suppose it is a surface, if it is a flat surface or it is a mirror, so that cannot be measured, because in that case we will not get any intensity back. So for that case, we can take the observation if it is perpendicular to each other. If it is not, the observation will be either very long, either you will get no observation. And in case of direct sunlight, the measurable distance may be shorter. So if the case is direct sunlight, then what you have to do, you have to put a shadow on the target. Then you have to take the observation. So these are the things which you have to take care in case of reflectorless mode, not in the prism. So this is the screen of the Trimble M3. You can see there are many options like general survey, settings, internet setup, files, internet remote support. So whatever we do in this case, we use the general survey options. So this option you will get once you open the Trimble Access software. So the first step is that you have to open the Trimble Access software. Then you have to go in the general survey. In that we will get the options of jobs. Here you can see in jobs you have to create a new job. What are the parameters, what are the coordinate, what are the settings you want for your job, you can select here. Then after creating the job, suppose here the job is JAM941. So once the job is created, you have to click on the measure, this option. So in measure, first what you have to do, you have to do session setup. You can see the options in measure: session setup plus, resection, offline. So in session setup, you have to provide some information like what is the instrument name, what is the station code, what is the instrument height from the ground. You have to put the coordinates of that station point over which you have placed your station. So in this case, you can provide any value, but in many times when we have to analyze the things, we avoid taking the negative values. So for that case, we generally take 1000, 1100 meter as per the distance we have to measure, so that we can we have not to get any negative information, means negative measurements. In session setup, you can see here we have provided instrument point name. If you are giving any coordinate is okay, like STN here. What is the instrument height? And what is the coordinates of the points which you are using as the control point or station point? This was the first step. Like I said, no, you have to create a local coordinate system. So for that case, what we can do, we can take an origin. Okay, and once origin is decided, what we have to do, we have to set a direction from which direction we have to measure the angles. So for that purpose, what we do is backside. We have to fix our instrument in a direction, and we have to tell our instrument like this is the side which whose angle is 0, or this is the side whose angle is 90. Once your station knows like this is the side which is 90 degree to me, then it can measure any angle in the horizontal. And as you have leveled your instrument, then it is vertically 0. So in this way, once you have done the backside, means you have fixed your horizontal angle, you can take any observation. In our case, what we can do, here it is written, set the backside point by horizontal angle only. We have the options of that, selecting, and then input prism height, whatever prism we have to take the observation, and azimuth angle 0. It's on us. Like if I want to make north 0 degree, then I have to put my prism in respect to your station, and we have to make it 0. If I want to make that angle 90 degree, then I have to tell the system like this is the direction where the horizontal angle is 90 degree. So it means you need one point whose coordinates should be known. You have to place that your instrument on that point. So first thing is clear, like there is a point whose coordinates are known. Second thing is that what is the direction of 0 angle, direction of 90 degree angle. You have to tell that your system. For that purpose, we will go for backside. Once you have done your backside, then your system setup is done. Sorry, not system setup, it is station setup. So once station setup is done, now you are ready to take the observations of the surface or whatever you are mapping. So here, once you go in the measure option, you have done your station setup. Then you have to select the option of measure topo. Here you have enter the name of the point for which point you want to take the observation. And in method, you have to select the method of angle and distance. Then it will measure the angle and distance both for that point. You have to enter the target height. It means wherever you have placed your prism, what is the height of the prism. Or if you are not using prism, you are in reflectorless mode, then you have to provide the height of that point. So after that, you have to focus your telescope, your crosshairs on that prism or point. Then you have to measure you have to take the measurements. Suppose I am taking the observation for P1, P2, P3, and P4. So there are option you can see here in this window. It is written map. Once you have taken the many points, you can click on the map and you can see the map. So in this way, you can do a basic survey. Suppose there are many points on the field which cannot be covered from a single instrument point, a single station point. In that case, it may be required to change your station point. Suppose I am standing with my instrument at one place and I am taking the observation. But there are other points which are away from me or not in direct sight. Means directly my system, my instrument cannot see that point. In that case, you have to change your station point. Means you have to do a station setup at another point from where we can observe, we can take the observations of other points. So for that case, you have to place your station from one point to another point. So in that case, after taking the observation from one point, you have to put your system in standby mode. Then you have to take that instrument to the another point, put there. Then you have to do again system setup, which we were doing after creation of jobs. So again, you have to provide the coordinates. You have again do the backside. After doing that, your station will be ready. Then you will be taking the observations. So this is the same. There is an option. You can set tool in this Trimble M3, which is called coordinate geometry. So once you have created a local coordinate system, you have taken the observations. So you can do then what you can do. You can do some basic calculations using the coordinate geometry tool, like what is the total length, what is the total area, what is the perimeter. These all things can be calculated using the coordinate geometry. You can see the options here: compute inverse, compute point, compute average, azimuth. These are. So after taking the observation, you have to export your data from the your Trimble M3 instrument to the means in any format like Excel or anything. So you can see here, once your job is done, you have to right click on your jobs. You have to select the option of import and export. There are options. You can use anyone .csv, .shp, .dxf. Then you have to export your file, and then you can use the USB cable or you can use the Bluetooth, and you can export your file from, means you can take your file from that instrument. So here you can see in the screen, like they are exporting a point which is amil.csv. So the data is being exported in the CSV format. It is also given in that CSV or Excel what will be the columns. So the first column will be showing the, which is field 1, it will be showing the point name. Second one will be giving the northing coordinates. Third will be easting. Fourth will be elevation, and fifth will be the point code if you have provided. Otherwise, only point name and coordinates, north, east, and elevation. So this was about how you can you have to use the total station, Trimble M3 total station in a survey. Okay. So to establish control networks, you can say we use traversing. In traversing, we have to means how to define a traverse. So a traverse series of connected lines whose lengths and directions are known. So there are two types: closed traverse and open traverse. So in closed traverse, you have from which point you have started your survey, you have to close your survey on that point. Okay. In the case of open survey, the beginning and the end point will be different. Second thing was contour. So what is contour? Contour is an imaginary line on the ground joining the points of equal elevation or reduced level. I think you must have studied contours in your coursework. Isn't that? Shivam?
Yes, sir.
Have you studied contours in your coursework?
Yes, sir.
Okay. So this is very simple to you. So contours are imaginary lines which are showing the equal elevation. Suppose this is the case for where we can see the lines drawn on 1000 meter and 2000 meter. So it's, if we see from the top view, we can see the 1000 will be will line can be drawn like this small circle, and for 2000 we can see like this. There are many different aspects we can see here. Second is contour interval. The difference between two contour lines is called the contour interval, and the horizontal angle, horizontal equivalent. It is the horizontal distance between two contours. So basic definition. So this is how, if you are looking at two contour lines, suppose these are two cases. The first one is this, second one is this. If you are looking at your contour lines and it is means well separated, you can say it is a general slope. But if you are seeing like this, they are converging then diverging. So then there may be the case of steep slope. There are one more very interesting option is that. So if you see a series of closed contour lines on the map representing a hill, how if the higher values are inside? If you're looking at the contour, you are looking at the contour and you are seeing that when the circle is going to be small, these lines are going to be small and the value is increasing, then definitely it's a hill. You can see it side view and top view also. And it's opposite, if this value is increasing from inside to outside, then it must be a dictation. So based on your surface, the contour will be different. So this is how you can interpret with your contour maps. And if this is the case, they are starting off, you can see they are starting from a single point like this. Generally it is called like they will not cut, they will not meet. But if it is the case, then simply you can say there is a overhanging cliff. You can see here this point. At this point, all lines are meeting. So these are the examples. Here you can see the vertical cliff. And this is directly showing this line. So these are examples of contour. You must be using ArcMap also. So if you are having some point data and you know the elevation of these points, you can directly plot an contour map in the ArcMap. How you can do that? Suppose you have some CSV, like you saw that amil.csv. You can load that in the ArcMap. You can click on the display XY data. Once you do that, then it will ask for the options like XYZ. Whatever it is, maybe northing, easting, it may be latitude, longitude. And when you click on the OK, you can see the points shown on the map. Suppose we are using another points here just to show you. Then you can use the Arc Toolbox. In Arc Toolbox, you will get the option of Spatial Analysis Tools. In Spatial Analysis Tool, there is the option of Surface. In Surface, you'll get the option of Contour. So you will double click on that. You will get the options of providing your input layer here. Once you provide, you can see this is the contour map generated. So this is how you can generate contour map in the ArcMap. one more information what I can give you. You can see here many this these small circles like this, like this. So very simply, you can say this is a mountainous region. This area belongs to actually the Srinagar in Uttarakhand. So this is the city place, and after the city, these are all the mountainous places. So for that, we have generated the contour map here. So any doubt on that? Sumit,
Yes, sir. No doubt.
if there is a note, please raise your hand. I have to show 2 to 4 small videos are there. But these videos are not joined. Okay. So you can see this is the tripod, and these are how the legs are locked. So we can open their legs. First of all, you have to unlock this the legs of the tripod. And I'm maintaining a proper height. You have to place your tripod over any station point, whatever you want. And second thing is that, so this is the point over which we have to place our tripod. So we have to try to manually place over there. And this way you can manually check the leveling of your tripod. So initially what you do after placing your tripod over the station point, we'll be checking like this. How much difference is there? Is it leveled or not? So manually we will try to, first of all, we have to try to level it. Then once it is leveled, then you have to take your instrument, the gimbal amplitude station. We have to take it very carefully, and you have to place it over the tripod. Then this is the mounting screw, you have to fix it. And the next one was, yes. Now you can see here, I have tried to do centering, but you can see there is this, no, there is a circle between, which is not just at the control point, center of the control point. And you can see the water bubble also, that is showing it is not leveled. If it is leveled, then water bubble will be in the center. So So in that case, you have to use there is a lens given in the tool station. You have to use that, and you have to place your system in this setup just over the control point. This is I'm using leveling screw to level it. Okay, so this was a very brief introduction of total station and small videos that how you can do station setup. So in the next laboratory session, what I will try to do, I will try to give you a live demonstration like how you can use the total station. So we'll be on the field and showing you how we are doing the station setup. We are placing our instrument over the tripod, and we are, setting up the prism and all, and we'll be taking the observations. So that will be shown to you in the next laboratory. So if there is any doubt regarding this today's class, please let me know.